I spend hours every day right here, and it can get lonely. So lonely in fact that I had to adopt some pet plants. I should probably go outside and touch grass, maybe spend more time with my friends and have some real human-to-human interactions, or I could just build a damn robot to fix all of these problems and do a whole lot more. Okay, I know what you're thinking, this is just another pointless AI product no one is asking for. And I'd agree with you, except my Mechatronics professor quite literally assigned us a final project worth half of our entire grade, which is due in exactly 1 month. And the prompt for the assignment is to build a robot. Now this is such an open-ended prompt that I had to dig deep down for some inspiration. As a kid, I was always inspired by the world of Pixar and Marvel, so I knew I wanted this robot to have this cartoony sort of charm to it. And after brainstorming with my group, we came up with an office assistant inspired by Jarvis from Iron Man. Hence we're gonna call this robot Jarvis. Real creative, I know. With a rough mood board drawn out, phase 2 of the ideation process was hopping in a blender, and after twiddling around for some time, I got this thing. Now it looks very basic, but I'm going to refine it and build this out in an actual CAD program, which is a problem for another day.
Oh man.
With an endless amount of possibilities for the robot, I want to introduce the first lesson of the video, which is setting realistic goals. You see, any project you want to work on has 3 major constraints, which make up what I like to call the triangle of doom. One corner is your budget, another is time, and the final one is the scope of the project. Pulling any one of these corners increases the triangle of doom. So the more features you want to add to a project, the more time and money it'll require. And the opposite effect is true as well. I truly believe that given an infinite amount of time and money, anything is possible, but with only a month to bring this project to life, we spend an entire day figuring out our top 3 most important features for the robot. And you'll have to wait till later in the video to see if we got these working in time. It was tempting to pack the robot with a bunch of random electronics and smaller features, but these key requirements kept us focused on what actually matters. I spent the next few days working on the design of the robot, triple checking every dimension, standardizing every hole, and this was going to be it. I was going to print the final robot first try. I placed the parts into Bamboo Studio, and when the printer finally finished, I had done it. All the parts turned out perfect, and the CAD model worked first try. Yeah, just f***ing kidding. The servo wires wouldn't fit through the bracket, the USB-C cables didn't fit through the holes, the neck of the robot was too short, the neck was off-centered, the Raspberry Pi placement was off, cables didn't line up, so lesson number 2 is to accept failure, because it's inevitable. Even though I'm going to college for mechanical engineering, my previous CAD models haven't necessarily looked the best. But I made it a personal goal of mine to make the mechanical design as sleek and compact as possible while keeping that cartoony charm to the robot. This meant refining the CAD model no matter what failures I encountered, instead of cramming all the electronics loosely into the base. This really pushed me to get creative with the ways I solve problems, and I'm honestly proud of the final results. So to conclude lesson number 2, you gotta embrace the failures and use them as guides on how to improve in the future, instead of as an excuse to quit. Now, it can be daunting starting a new project or even getting into the DIY space as a complete beginner. If you're watching this video, chances are you're probably already interested in or studying some form of engineering in school. So I want to tell you the number one thing I wish someone had told me when I was just starting out, and it's that you don't need to be an engineering expert to create cool projects. Take a look at the electronics for JARVIS. We're using 4 micro servos, a speaker, web camera, and a Raspberry Pi. That's basically it. And I'm no electrical engineer, yet I managed to work my way through the assembly process of all the electronics by remembering 3 key things. Number 1 is to make sure you're using the right voltage for all your electronics. Number 2 is to have enough current to power everything. And number 3 is to always keep all your grounds combined and shared across all the electronics. I know people won't like to hear this, but you can honestly ask AI how to wire everything up to make sure nothing's going to explode. And that's basically all you need to do to get started with building your own robots. Over time, you'll obviously improve on your skills, and once you gain the confidence, you can create custom PCBs and solder all the components together to minimize the space the electronics take up, unlike what we did for Jarvis over here. Oh, also, if you're working alone, don't get discouraged. It can take a lot longer to learn all the skills necessary to build out your dream project, but trust me when I say that seeing your imagination come to life, knowing that you did it all by yourself, is the most satisfying feeling ever, and it makes you feel like you can do anything in this world. So this is the part where things kind of went really wrong. My Raspberry Pi unexpectedly stopped working, but it was practically new. So I went back and forth with the manufacturer, and this delayed our project by 2 weeks, which is time we can't really afford. I eventually had to bite the bullet and buy a new one, but the worst part is that we waited way too long to integrate everything together. And that was a big mistake. So the team and I grinded the programming for days on end, slowly chipping away at each task we set out to make. But it felt like when we fixed one thing, another part of the code would break. And I'm not going to bullshit you guys, a lot of AI assistance was used to write the code. But by staying organized, we managed to barely get everything working just in time for the demo day. Showcasing your work is yet another satisfying aspect of building your own projects. And I think my professor knows this too, because tomorrow is April 29th and we have our final day of school and have to create a showcase demo for our final project. Aside from showing friends and family your final work, making your projects open source is another great way to get constructive feedback and advice from others who might just have a little bit more experience than you do. Plus, you never know if posting your projects online could gain a bunch of traction and turn into an actual business venture. Oh, and don't worry, I didn't forget to show you guys JARVIS's 3 main features, which are human recognition and facial tracking, audio communication.
What's 64 divided by 12?
64 divided by 12 is approximately 5.33.
And computer
I've
assistance.
set a Google task for you to finish your Mechatronics.
So with that being said, I hope you all enjoyed the lessons from this video. Consider subscribing if you want to learn more, and I'll see you in the next story.